Jau online. Mums kategoriski vajag putrot smadzenes. Tā. Kur tu esi? Iekšā. Tī. Whoa, I have one yuan one. I'll start in 15 minutes. 5 minutes. Hallo, hallo. Free me. get there. Get there. You. Yeah, operation, everything fine. Boom, 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 boom. Where I am, what I'm doing. Needs to go forward. John Baptiste Joseph Fourier. Born 21st March 1968. Jean-Baptiste Joseph Fourier worked in the area of thermal engineering, mass, and so on. Jean-Baptiste Fourier started to thinking, I have problem when I'm outside of harmonic functions. I don't know what to do. I need to somehow perform integral calculus, differential calculus, and so on. I have problem, but possible I can solve. What the idea of Jean-Baptiste Fourier. Switch back to my signal and need it. I have problem, I need somehow to deal with complex functions. Let's say Fourier started with periodic function. In our term, I have a periodic signal. Fourier idea, if I cannot deal with it directly in easy way, maybe I can try to decompose it. What's the idea? Idea is to substitute our term signal with a row or series. I start from 1 to infinity of here some easy functions, some easier functions. Maybe I can substitute my complex function with set of some kind of easy function. What can it be? What means easy function? Easy to integrate, easy to take derivative. But in terms of modern math, this means to create an image, or I would say reflection of my signal in the space of functions. To create a space, remember my tiny demo, when signal was, represented as a function of signal. With such a figure, here I need to create a system of coordinates. Cartesian system of coordinates. X3. This is Cartesian coordinate. First, I need to set directions, yeah, by vectors. But that's not all. What I need? One meter, centimeter, millimeter, inch, I don't know, anything. I need to set a unity, a measurement unit of coordinate system. To do something like this in functional space, first what I need set of function to create a coordinates. If two vectors are like this, how do we call them? Orthogonal. Yeah? Something familiar? So we need system of orthogonal function. We need system in such way integrate from minus infinity to infinity fi not t f not t. The t is 0 for any I starting from 1 to infinity, from any j starting from 1 to infinity. No, of course, not by self. Constraint or covenant of orthogonality. Function system must be orthogonal. Not an easy task, or maybe, I don't know, maybe even must heard it as a zero correlation. Orthogonal system is a system of function with zero mutual correlation, completely independent. If there would be a correlation, this will not be, something like this is not a coordinate system. You cannot create coordinate system with parallel vectors. This will not work. This condition isn't easy to maintain. The key problem, you need as it written in infinite time. But there are good news. Since I started with periodic signal, I started with here an integer with periodic signal. It's sufficient for me, it's enough for me to perform this magic for one period. Because everything repeats. If I can do it for one period, I can use limited time correlation. Only what I need this space being great when period. I need to one period, one repetition. I need from here to fit inside T1, T2 orthogonal space. Next, this is if I have system of orthogonal functions, this is not enough. I need to have unity base. I need what? Grading. Infinity fi square not that. I should get 1 for any y from 1 to infinity. I need a unity base. To get so, actually, okay, I can limit my time space, but good news, if I have a system of orthogonal function, this is a condition of orthonormality. Or if I have function system which fulfills this condition, I have an orthonormal system. No problem. If you need, just use normic factor 1 divided by square root. Can do it this way. Square. And everything will be fine. You can easily convert orthogonal system to orthonormal. Fourier started with what started Fourier? Fourier took very nice familiar system of functions. I don't know how in your country we have tradition here. Every school has, of course, a math room, and each math room has this object, unity circle, where here it's written cosine, sine, of course it should be by 6, by 4, something like this. Familiar? What's in your country, in your tradition? Is it one of the must objects of math classes? Unity circle.
I couldn't recall. I was given that.
I personally hated it. Many years sitting and working at this. But what do we see? When cosine has a value of 1, sine 0. When sine is 1, cosine 0. That means what system like sine k double p divided by cosine k double p for k starting from actually we can start from 0 on up to infinity is orthogonal, yeah? They always 90 degrees. But it's orthogonal in, we need to be something like should be somewhere from 0 to double p. It's orthogonal in limited space. Yeah? But it works. Fourier used cosine sine. Nice harmonic function. What's good in sine cosine system? Integrated cosine, we get sine. Integrate sine, we get cosine. Same with derivative. We always dance about harmonic function. And what we knew about harmonic function? Yeah. No distortion. Good function. So, let's say we have orthogonal system of functions. Now, we substitute signal, remember, we substitute signal from even from 0 to infinity. A k, f k, not that. This one set of function. Fourier offered sine, cosine. What about this beauty? Factors. How many sines and cosines should I take? In general, if it is possible to find this factor in the way what this will be true, we have complete or full system of function. But how? I need set of factors ensuring best possible precision. But how do I evaluate precision? And here, one important moment. Fourier offered to use Euclid norm as a precision. To get best possible factors, Fourier offered to use starting from minus infinity. A K F K not square you may substitute with 0 to time to period if we have periodic function. But here is Fourier criterion of precision. What means close or not close? His idea. In general, it's something what can be watched as a difference energy. But this criterion is integral. It's for time period. Such criterions mean what? What means? What do you mean criterion? Such criterion means what row or series will disregard small but sharp changes with small energy. Something like this, sharp spike with large magnitude but small energy, because it's sharp, it's thin. Something like this will be ignored. If we go Fourier's way, it's easy to get sorry, I need to do this. Wait, 0 I need to solve partial differential equation system. Solution is known, Fourier did it, so A equals to integral from 0 to period, S not T, F entice not T, T. Solution is known. So Fourier's orthonormal system is Fi square root 2 divided by time cosine I double P and one, oh, this, okay, not important. cosine double I minus 1 double P divided. Here, this element is a norming factor, and sine and cosine form here I starts from 1 and up to infinity, something like this. Also, f0 simple square root 1 divided by t. Something like this. Usually, norming factors are combined with series, with function factors. And classic form of Fourier series or Fourier rule looks like this. Periodic function, in my case signal, can be written as C0 divided by half plus sum, in case starts from 1 and to infinity, ck cosine k double p divided time plus s sine k double p divided by period multiplied by time. It represents periodic signal as a sum of DC component and multiple harmonic or AC signals. Here, C is a cosine factor and S is a sine factor. I can rewrite it to make it clear. S C0 divided by half plus sum. Who's writing sum like this? K starts from 1 to infinity of a k cosine k omega t plus p k, where square root ck square plus sk square, omega frequency double p divided by period, and angle is minus f tangents of sk divided by ck. Here, absolutely clear, periodic signal, according to Fourier theory, can be written as one DC component and multiple AC component with frequencies. Signal frequency, double signal frequency, triple, and so on. K omega t. With magnitude A and phase angle phi. How can I get cosine and sine factors? What your Facebook tells, how can I get them? I see my lecture is not interesting. Maybe you can answer, how can I get them? With Fourier transform. You pushing me on the out of terror. So cosine factor can be found as double divided by integrating within period cosine double P. Yeah, integrate in time. Sine should be divided from 0 to time. My signal sine of double P divided by time dt. Here are basic. Take a picture. These are basic Fourier transform formulas. Again, I will write it again. Periodic signal can be represented as one DC component plus sum of multiple AC components, harmonic components or harmonics. Each element A is called harmonics. Harmonic. Together, harmonics. Going forward, I have nice cosine here. There is a Euler formula. Cosine alpha can be represented as a power of alpha plus a power minus j alpha divided by half. Euler's formula can be applied. You took a picture? Yeah. Euler's formula can be applied. Alpha. If I apply Euler's formula, I can write my signal as 1/2 of sum by k starts from minus infinity to infinity, ak complex a power omega t. Here, complex magnitude is a k a power j phi k or ck minus j s k. Complex magnitude of phasor of harmonic. AC current can be represented with the phasor, yeah? What about electrotechnics theory? Here is basic of electrotechnics theory. Take K1 and you get basics of phasors. What else? What next? Next? One moment. I can get my harmonics directly as double divided from half of period minus half period of period a power minus dot k double p divided time. This is Fourier transform formula in complex form. One moment, in complex form, we, in real form, in form of harmonic function, k always positive. Single frequency, double frequency, triple frequency, and so on. Here, we have both negative and positive frequencies. That's because of our formula applied. What means positive, what means negative? If I look on complex plane, here is AK with a dot. It rotates forward with speed k omega. Understand? It has its mirror or conjugated A minus k. In Fourier world, negative frequencies are conjugated, are mirrored to the positive. So, with negative is a conjugation of positive. What means conjugate? What means conjugate? Opposite sign of imaginary part. If x is a plus dot b, its conjugation will be a minus dot b. They are conjugated. What I need? Knowing so, I can write a 0 by half plus real part. Sum by k starts from 1 to infinity. A k a power of k omega t. Sum of number and its conjugation produces double real part. Okay. Now, let's take a small example. Our highly unclear signal. Rectangles. Let's look at rectangles. Minus t by half. This point is t by half. This magnitude minus a. Here, magnitude e. This one. Let's try to take a look on our offender. We saw the signal, and what we saw? Distortions. Distortions. So, what's a match for such signal? Equals to minus e plus 1 plus 1 t by half time double n plus 1 and a double n p by half time n plus 1 p by half. Here is a mass definition for my nice rectangular signal. I need to get Fourier transform or Fourier I need to perform Fourier transform. I need to get it in form of Fourier series. So complex magnitude of harmonic number k, here with n is integer. Will be 2 divided by period, integrate from minus by half to t by half, as a power minus j k double p I need to calculate this. My integral will split in two, half and half. I will, so a key is, let's go forward, double a divided by period. Here will be minus t by half to 0 a power minus k double p divided by period time minus from 0 to half period, same a power minus j k double p divided by period time in time equals to oh, I wrote this during financial committee meeting, so it has a bit of smell of money. So I will get double E divided K double P multiplied by a power minus j k double P divided by time in time starting from 0 at n t by half minus a power minus j k double p divided by time in time minus t by half to 0. Oops. Equals to A divided by minus j kp double minus a P plus a power JKP. This one, again we see Euler's formula. This will yield me double cosine of JKP. KP, sorry, J will disappear. So I'm rewriting this as double E divided by JKP 2 times 2 cosine of KP. Double. Why double? One. Why double? And it goes there. Now it will be double A JKP multiplied 1 minus cosine of KP. Oh, here it is. If K is 0, what will we get? Cosine of 0 is 1. 1 minus 1, 0. Meaning what? A 0 is 0. And what about A2? Cosine of double P. 1, 1 minus 1. 0, nothing. 0. So any A double E will be 0. Nice. What about A1 double A divided by JP, 1 plus 1 yields us 4A divided by P, A power minus P by half. In the same way, A3 will be double A 3 JP a power P by half and so on. I can write now time series of my example. It will be equals 4A divided by P multiplied by cosine double P divided by time minus P by half plus plus 1/3 cosine minus P by half plus 1/5 cosine, here should be 3, of 5 double P minus p by half, and so on. Goes. If we shift cosine by 90 degrees, we will get sine. So finally, I can rewrite my series like equals OE divided by P multiplied by sine omega plus 1/3 sine 3 omega time plus 1/5 sine 5 omega time, and so on. OE divided by P multiplied sum when I starts from 1 and ends to infinity. Double I minus, wait 1 second. Sine of double I minus 1 omega time divided by double I minus 1. I need to rewrite it. Sine double I minus 1 omega time divided by double I minus 1. Nice writing. One moment, I will get my tool. Operation. One, 1/3, 1/5. 1/3, 1/5. Let's see. What I got here. Okay, 500. My good old generator, this base unit, supplies me ideal harmonic signal 500 Hertz. But I have this unit. It's a set of multipliers. And this one is set of scalars. If look at what written on the blackboard, I need to get rectangular signal, I need to add 1/3 of triple frequency. Let's add 1/3. Now signal contains two components. Base component, I can switch it off, and component of triple frequency plus 1/5 what it contains now. One of the base 500 Hz plus 1/3 of 1.5 kilohertz plus 1/5 of 250 Hz. And you see, any of them is nice harmonic function, yeah? But apply it all together, they give me something close to rectangular signal. Only base. Appears what Fourier idea works, yeah? Wait. I have one experiment. here is my little device. My device, capacitor, coil, capacitor. This is input. This is output. Capacitor is 15 nanofarads, coil 4.4. My coil is 4.4 millihenry. I forgot wires. Connection cables. There are never enough cables. Yellow line will be input signal. And blue line will stand for output. Let's try to change frequency. Frequency. Higher. No. Long. I think this one is good. I only need to set angles correctly. Oops. I'm changing phi5. Here, what do we see? Input is approximation of rectangular signal. Yeah? With the frequency 19 kilohertz. Output is nice harmonic signal with frequency 19 kilohertz. Now, you know what this near rectangular signal can be represented with this close. Okay, let it be. With Fourier law. Can you explain what's going on now? This is resonance circuit. Blue line output. This is blue line and I have yellow color. Yellow is input. What's going on?
Signal is disrupted.
Look at that. This is resonance circuit. Yeah? Yeah. Its resonance frequency, okay, F0 will be 1 divided by double P square root LC. If you perform calculus, you find what it should be 20, but bit in precision, I get F0 approximately 19 kilohertz. What do I know about my signal? It's formed as a Fourier series. It has 100% at 1 omega, yeah? One third or 33% at 3 omegas, yeah? And 1/5 or 20% at 5 omega. When 1 omega corresponds to 90 kilohertz. For this circuit, I draw it. For resonant circuit, magnitude or body of transfer function or body plot looks like this, like, I don't know, couple, not couple. At this moment, I have F0 equal to base frequency of signal. See, they are equal. And I see nothing else but base frequency filtered out. Look, I disconnect 3 and 5, higher harmonics. Nothing happens. I disconnect base frequency and signal disappears. 100%. It's a base component, first harmonic, filter it out. If I can filter out base harmonics, should be possible to filter out third, okay, decreasing frequency, 19 divided by 3. One moment, I will get it. Oh. What do we see now? 6.4 base frequency and 19 output. Yeah, hello. Нет, а что хочешь? Нет проблем. Отдыхайте. Okay, what do we see? Now, here is my diagram. If we have all harmonics, it has name of spectrum. This one is spectral diagram, relative weight of harmonics. Now my filter, my bandpass filter, is still tuned for 19 kilohertz. I changed nothing. But I have shifted the whole spectrum to which frequency? It starts from 6.4. And what happens now? You see what there is a factor 3 between them? Yes. Now we see component of triple frequency. I can prove it. I switching off base, nothing changes. I'm playing with triple, changes. Fifth, nothing changes. So it's a third harmonics now. And what? We should see one more. I should be able to catch the oh, here it is. Component number 5. Yeah? Let's check. Changes. Not changes. With the bandpass filter, I proved what really this signal is sum of base frequency plus triple plus 5 times. Okay, I can do one more demo. This one is clear. What happened? How it works?
Well, there are several signals, and in this case, I think it's a third one is harmonic. That's why when you change the base, the first, the second, and the fifth, it doesn't affect the.
Yeah. I have a bandpass filter cutting one how to say, part of spectrum, cutting in frequency. My signal has it's a sum of 3 frequencies. I can cut one. If I cut one, it's ideal harmonic signal. Cut another one, again, it's ideal harmonic, but they all together approximate my complex. Why we saw distortion on, for example, with low pass filter? Low pass filter cuts high frequencies, so only this part remains. And one more problem. Low pass filter not only changes magnitude, it changes also angle. Remember? The higher frequency, the closer angle was to 90 degrees. Distortions are in terms of Fourier law, because higher if it is a low pass filter, higher harmonics are down in magnitude and shifted in phase. In case of high pass filter, low frequency part of spectrum is distorted. One more demo. 1 second, I'll bring my favorite scoop. where am I here? Let's say 800. My vertical channel is 800 hertz and my horizontal channel will be 400. No, maybe here better not to look at vertical, but here. Vertical channel 400, horizontal 8. Enlarge it. Oh, one nice research figure. Some bit closer. Oh, one nice research figure. 800 on horizontal, 400 at vertical. I'm adding. Now it has 1/2 of second harmonics. At this moment my signal has 50% of second harmonics. Would be nice to get it to scope. One moment. I can use 1 second, it will become operational. Come on. Signal, come back. I will not. Hurt it. Yeah. I'm changing angle of second harmonic. I will freeze it. Research figure when signal has around 50% of second harmonics. Oh. Signal with a high presence, oh, okay, 1/2. Signal with 1/2 of the third harmonics. And in addition 20% of 50. This very strange and unusual figure is when contains third and I'm changing the angle of fifth harmonics. Oh. Distorted voltage. This technique was used by now disappeared old maesters to analyze spectrum composition of signal. Okay. Time to ask questions. Any questions? Who am I? What am I doing here? Yeah, I understand. What's the... What the... What's the key idea of today's lecture? What any periodic signal can be represented as a sum of harmonic components. Yeah? Yeah.
In sine, cosine.
Yeah, sine, cosine, and exponential. What it gives to us? When we need to perform calculus on any periodic signal, what we can do?
Using formula.
We can decompose it as Fourier law. So, and then use superposition theorem. Remember superposition theorem? Yeah. So, what any regime of complex network can be split into partial regimes when we connect energy sources one by one. Here we can connect our one DC component and multiple AC components one by one. Get partial regimes, put them together with all together with Fourier synthesis, and we will get real true regime. Fourier series is a way to transfer non-harmonic signal into set of harmonic. And our electrotechnics theory Viena. Ta. I have tiny problem. We have calculus techniques in electrotechnics. 4. What's wrong in this list? Oops. Let your phone rest 5 minutes and ask me what's wrong in this list. Answer me.
Oh, well, there's only 3 of us present in a total of 9 students.
Where is your mark? No, yeah. No,
Yeah, I have 8.
yeah. You see? Boomer.
Yeah.
What's wrong? You have scanned your NFC.
Yes.
Actually, I didn't take my NFC.
Ah, that's why you not appear. Understood. Okay. Because I have I have 3 students, but appears for only 2 scans.
Well, Circus says maybe one of us is a ghost.
Yeah, I don't like ghosts. I can take holy water and watch circle also to solve this problem. Okay, this means what I can left this building. I see no online questions, so I will end.